The question we are solving now belongs to test series 6. It is of control system subject. In specific, it belongs to basics of control systems. As per the question, there is a signal flow graph which is as shown in the figure. The signal flow graph is the interconnection of the nodes as marked. R of S is the input and C of S is the response. And we see that the different branches marked have gains of 2, 1 by S and 1 by S and 1, and there is a feedback path as shown in the figure, and the feedback gain is -1. Similarly, there are two more feedback paths which can have a gains of -1 and -2, and the second forward path has gains of 1, 1 by S and 1. Please note that there is another loop, another forward path that is coming into picture as shown, and it has a forward gain of -half. We need to find the transfer function of the signal flow graph as shown in the figure. We see that the signal flow graph transfer function can be obtained from Mason's gain formula, and for Mason's gain formula we need the forward path transfer functions P1, P2 and P3. We see that P1 is a forward path which covers the points 2, 1 by S, 1 by S and 1. So it has a gain of 2 by S square. P2 is a forward path which covers the points 2, 1 by S, 1 by S, 2, 1 by S, 2, 1 by S and -half, which can be written as -1 by S, and P3 can be written as a forward path covering 2, 1 by S and 1, that is equal to 2 by, P3 is covering 1, 1 by S and 1. So P3 is equal to 1 by S. Now let us consider the three of the individual loops. The loop gain of L1 is -1 by S. The loop gain of L2 is -1 by S. And the loop gain of L3 is -2 by S. From this we see that by Mason's gain formula, the overall transfer function T can be written as P1 delta 1 plus P2 delta 2 plus P3 delta 3 divided by delta. In this, we know P1, P2, P3, we need to find the delta terms. We know that delta 1 can be written as 1 minus L3. Here L3 has come into picture because of the reason that for the forward path 1, the loop 3 is untouching. So this can be written as 1 plus 2 by S, that is equal to S plus 2 by S. So similarly, we can write delta 2 as 1 plus 3 by S plus 2 by S square, which can be evaluated as 1 minus of L1, L2 plus L3 plus L2, L3. And delta 3 can be written as 1 minus of L1 plus N2 plus L1, L2, which can be written as 1 plus 2 by S plus 1 by S square. And the delta can be written as 1 minus of L1 plus L2 plus L3. This is the delta term for the overall signal flow graph, plus L1 L2 plus L2 L3 plus L3 L1, which is further added with L1 L2 L, which is further subtracted with L1 L2 L3. And we see that this upon simplification can be written as 1 plus 4 by S plus 5 by S square plus 2 by S cube. From this we see that the overall transfer function T can be written upon substitution into the given formula as T is equal to S plus 3 divided by S plus 1 whole square multiplied by S plus 2. This is the transfer function of the overall signal flow graph given. From this we see that the correct option which represents the transfer function of the overall network is A.